The last type of permutation we're going to look at is called a circular permutation. So what we have been doing so far has been looking at linear permutations. So they give you an example here to kind of show you why circular permutation is different than linear permutation. So looking at these two rows right here, okay, and notice the difference of them. This one starts with salt, then goes pepper, yada, 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 all the way down to curry. If I look here, it looks like everything was just shifted one to the right from my original one over here at the left. Okay, so when I do that in terms of a linear permutation, that actually changes up my entire permutation. It's a completely different scenario. However, if I arrange them in a circular order, like so, now it's really not any different. Okay, even though they're in kind of a different location, they're still in the same order if I go around in a circle. Notice on the left I have salt, pepper, ginger, thyme, curry, and then if I come over here to the right, they were shifted one direction to the right, but if I don't know where I'm really starting, it could be the exact same permutation. So that leads us to the idea of, if we don't have a fixed reference point, and that is a very important part, whether you have circular or not circular, you have to have a no fixed reference point. You're going to take your total number and subtract 1 and then find the factorial of that. All right, so I'm going to show you one that they're both going to look circular, but only one of them is circular because one of them has no fixed reference point. Give you an example. In the 6 charms on the bracelet shown are arranged at random, what is the probability that the arrangement shown is produced? So we need to ask ourselves, it looks to be circular, but we need to ask ourselves, is there a fixed reference point? And since there is not like a lock or chain of some sort to put it on or off, we would consider this to be no fixed reference point, and therefore a circular permutation. So we have 6 charms, we subtract 1, find the factorial of that, it's going to get us 120. If I want them to be in this exact order for the probability, then we would say that there's only one way of doing it out of the 120 possibilities. Okay? Letter B. You're seating a party of 4 at a round table, so it sounds circular. One of the chairs around this table is next to a window, right there. As soon as they said next to a window, that automatically makes this from a linear permutation, or from a circular permutation to a linear permutation. So if the diners are seated at random, what is the probability that the person paying the bill is seated next to the window? So for our total, and then what we want, that's what we're going back to. Total, there are 4 people. They can all sit randomly out of there. And then for what we want the person next to the window paying the bill. All the other people can sit at random, so there are 3 different ways that they can sit at random on the table. We would find 3 factorial over 4 factorial, and when we do this, we would get 1/4. Again, that's something that you guys can plug into your calculator. The big thing, though, is knowing, is there a fixed reference point or not? If there's no fixed reference point and you're around a circle, you have a circular permutation.